I'm going to give a couple examples of multiplying polynomials. A technique that I like to use, I call it double and triple distributions, because it relates to what we've learned since elementary school. And so before I even do an example of that, I want to start off with this idea. Just a review of how to multiply simple two-digit numbers. If I said I had 31 times 25, if I were to multiply this using traditional multiplication techniques, we could go 5 times 1, which is 5, and 5 times 3, which is 15. And then how most students learn to do double multiplication, double digit multiplication, you should put a 0 here, and as you distribute that 2, everything is actually shifted over. So we go 2 times 1 is 2, and 2 times 3 is 6. And then once you get to this point, you add those two results up, and we say this is 5, this is 7, and this is 7. So we get 7, 7, 5. Let me do a second example of this, and then I'll move into the algebra idea. Let's do 17 times 34. Once again, 4 times 7 is going to be 28. You carry your 2. 4 times 1 is 4, plus 2 would be 68. And then when you go to multiply your 3, you always put a 0. Everything gets shifted over. So 3 times 7 is 21. Carry a 2. 3 times 1 is 3. 3 plus 2 is 5. And so we add these up. This becomes 8, 7, 5. And so you get the gist. You all know how to multiply two-digit numbers. With algebra, now here's going to be our first example where we multiply what we call binomials. Now, multiplying binomials means that you have two sets of terms. So you might say something like this: 3x plus 5 times 2x minus 3. And the way I'm going to do this multiplication is just like when you learned how to do your two-digit multiplication. I'm going to start, I'm going to go back and forth here. So I'm going to cover up this 3x, and I'm going to distribute the 5. Just like up here when I started by multiplying the 5 across the 31. And so I'll go 5 times 2x is 10x. And then 5 times negative 3 is negative 15. And then when I move to the 3x, just like I did up here with the 2, notice that I put the 0 and I shifted everything over. And then I multiply the 2 and times the 1 and 2 times the 3. When I'm down here, because I start with the rightmost term, I shift over. I'm going to multiply this 3x across the 2x minus 3. That's why I call it double distribution. As I multiply this, I'm going to shift all the results over. So in other words, 3 times 2 would be 6, and then xx would be an x squared. And then I move to the next part of my distribution. 3 times negative 3 is negative 9, and x comes along for the ride. Put my line, and just like up here, once you had your second distribution, you had to add the two results up. I'm going to add these two results up. Notice that the middle terms are lining up nicely. That's typically what you expect when you multiply binomials. Binomial, again, 2 terms times 2 terms. So when I add these up, this simply becomes a 6x squared plus x minus 15. One of the key features that I want you to notice, when multiplying binomials, I have 2 terms times 2 terms. I end up with 3 terms in my answer. That is what you expect. When you multiply binomials, you want 3 terms in your answers. That will be the rule. Now, as all rules exist, there are always exceptions. But in this case, for this first night, that's pretty much what we're expecting. We always want to see 3 terms when we multiply.